the lesson from today, 1.6 transformations of functions. I included on these notes, this chart that I had mentioned during class today. I'll post this separately as a PDF so that you have that just as a study tool in case you want to print it out. I'll also post this notes presentation to Google Classroom along with a link to the video. So the 3 types of transformations that we talked about were translations, so left, right, up, or down, reflections, flipping over the X or Y axis, and then shrinking or stretching, either closer or further away from the x-axis or closer or further away from the y-axis. So I'm going to go through each of these individually, and then I'll do an example for each one as well. I'm going to do vertical and horizontal shifts together. We talked about these first in class today as well. So if you are adding or subtracting some constant term to the entire function, right? So you have your initial function f of x and you're adding a c term, or you have your initial function f of x and you're subtracting a c term. That means that you're either moving the function up or down c units. So I'm going to use the parent function of the quadratic here, and we are subtracting 3. That means we're going to be moving down 3 units. And then for horizontal shifts, if we are adding or subtracting a value directly attached to the x term, that means that we're going to be moving or shifting the graph in the opposite direction of the sign. So plus c would be left and minus c would be to the right. So our initial parabola here is our parent function f of x. And then, like I said, I'm going to just do both of these at the same time. I'm going to move to the left 2 and then down 3. So we'll start at our original point, go left 2, and then down 3. And we'll do this for all of the points for the parabola. So left 2, down 3. And this would be g of x shifted to the left 2 and down 3. For reflections, I'm going to use the square root function. So if we're focusing on a reflection over the x-axis, that means that we're negating the entire function f of x. There's 2 ways that we can do this. We can either graph the original function and then just reflect it over the x-axis, or we can make our table of values and we can multiply our y values by -1. So for the square root function, this is only defined for values that are positive, right? We can't take the square root of a negative number. And I'm also going to use some nice numbers here, just so that we're only graphing whole numbers instead of approximating with decimals. So we have 0, 1, 4, and 9. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And I'll graph that here in green. So this is the parent function for our square root. Now, if we're going to reflect over the x-axis, we can count how far away we are from the x-axis. So 0, 0 is on the x-axis, so that's going to stay there. Our first point is 1 above, so we're going to reflect 1 below. Our second point is 2 above, so we're going to reflect 2 below. And that will be our reflected function g of x. If you want to see this in the on the t-chart, you can multiply your original y coordinates by -1. So 0, 0 again is going to stay the same. But in this case, we'll have 1, -1. Here we'll have 4, -2. And here we'll have 9, -3. And you'll see that this is our first reflected point. Here is our second. And then here is our third. I'm going to use the same parent function, the square root function, for reflection over the y-axis now. I'll do it in a different color here. So we'll have the same f of x values. Oh, I don't know what's happening to my pen there, sorry. And then if we want to reflect that over the y-axis, right, because this is negating just the x value here, not the whole function, we can count how far away we are from the y-axis. This one's going to stay again because it's on the y-axis. So here we were 1 away, so we're going to go 1 to the left. Here we're 4 to the right, so reflection will be 4 to the left. And then here we are 9 to the right, so we're going to be 9 to the left for the reflection. If you want to see this on your table of values here, you'll see now instead we're going to be multiplying the x coordinates by -1. So 0, 0 is our original, -1, 1 is our reflection of that original 1, 1 point. 4, 2 is going to translate to -4, 2, and then this will map to -9, 3. Okay, for vertical, stretch, or shrink, here we would be multiplying the whole function by some c value. If c is greater than 1, this will be a vertical stretch. Okay, that means that the function is going to move away from the x-axis. You can also think about it again, like if we are stretching something up and down, the parabola would get narrower. So I'm going to use the quadratic again as my parent function. Okay, so here's f of x. And here, right, my c value is 2. That's greater than 1, so that has to be a stretch. In order to apply that transformation, you're going to multiply, all of the y coordinates by the c value. Okay, so these values here. So my new coordinate point will be -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. Okay, we want this to increase more quickly. Okay, so that will be g of x there. And I do have this over here so we can see it a little bit nicer. On the Gravon Desmos, it's nicer than by hand. You'll see, right, that since it's increasing more quickly, the graph gets narrower there. For a c value that is between 0 and 1, okay, so a fractional c value, this is going to be a vertical shrink. Here, we should expect that the parabola is going to get wider because the values are going to increase, but less quickly. They'll have a slower increase. So again, same parent function. F of x. And now for g of x, you can build off that second column there, and you're going to divide the y coordinates by c. Okay, so now it should be multiply. So this one's going to be -2, 2. It should be -1, 1/2. This is 0, 0. This is 1, 1/2. and this is 2, comma 2. It's negative 2, 2, 1, 1 half, 1, 1 half, and then 2, 2. Okay, so we'll see that that gets a little bit wider than our original function there, and then same thing here. You'll see, right, that the green is a little bit wider than our original parent function x squared. Sorry for that typo there. I'll make sure to fix that. Okay, for a horizontal shrink or stretch, now we're going to have some value attached to the x. Okay, so this is directly multiplying the x value by some c value. It's the opposite terms for a horizontal stretch or shrink versus for the vertical stretch or shrink. If the c value is greater than 1, in this case, this is called a horizontal shrink. Here's where we're going to be dividing by our c values. And the horizontal shrink makes the graph go toward the y-axis. So again, I'm using the x squared as my parent function here. So we still have that negative 2 to positive 2. And if we want to calculate on the table, we're going to divide the x coordinates by c. So here our c term is 2, or our c value, I should say, is 2. Negative 2 divided by 2 is negative 1. The y values stay the same. Negative 1 divided by 2 is negative 1 half. Y value stays the same. This is just going to still be 0, 0. This will be positive 1 half, and this will be 1, comma 4. Okay, so a horizontal shrink, it gets closer to the y-axis, right? It's being compressed in these directions here. Again, this is a little bit nicer than my picture on Desmos here, but you'll see it gets narrower. For the horizontal stretch, here we have a c value that's fractional between 0 and 1. Okay, so it's the same process. We're still going to divide our x values now, in this case, by the c value. Just remember that division by a fraction is the same as multiplying by the reciprocal. So if we're dividing by 1 half, we're multiplying by 2. Okay, so negative 2 divided by a half is the same thing as negative 2 times 2. That's negative 4. Negative 1 times 2 is negative 2. 0, 0 stays the same. 2, comma 1, and then 4, comma 4. Okay, and this is a horizontal stretch. We should be moving away from the y-axis, right? We're pulling it to the left and to the right horizontally. It's going to look like this. Okay, so we'll see that that parabola gets wider. Okay, so here's that table. It has your shifts. It has your reflections. I don't think I did reflections yet, did I? Oh yeah, I did. I forgot about those. It has your vertical stretching and shrinking here, and then horizontal stretching and shrinking here. Here's how to draw the graph. here's how the equation changes. The order of transformations does matter when we're talking about transformations of functions. In general, you should always try to perform any horizontal shifts first, any stretch or shrink, whether it's horizontal or vertical, next, reflections third, and then vertical shift up or down last. Okay, you'll sometimes see in your textbook or wherever, it'll say to perform the transformations inside out, inside to outside, meaning inside being the closest to the X. Okay, so inside the parentheses and then work your way out in both directions, typically to the left first because that's where you'll see a shrink or a stretch, and then always at the end is going to be the vertical shift. Okay, so when we put all of these things together, the first thing we're going to want to look for is what are the different types of transformations. Here we're going to have 1, 2, 3, 4. So we'll have one of each. And then how do we apply them on the graph, or how do we make a table of values so that we can figure out the points? For working inside out, or in this order that we're given here, our horizontal shift is going to come first. So we're going to move everything to the left 3. The next one that we should be looking at is whether or not there's any kind of stretch or compression. In this case, we have a 2 here on the outside, so this is going to be a vertical stretch by a factor of 2. This is a reflection over the x-axis. And then finally, we're shifting up 1 unit. The parent function is still the quadratic function. And I'll show you how to do each one individually on both the graph and in the table. Oop. I'm not going to label these as g of x. I'm going to just label each column with what we're doing first. I just want to plug my computer in so it doesn't die. Sorry about that. So again, we're going to graph our parent function first. I'm going to try to match the colors here, just so it doesn't get too messy. Okay, so here's our parent function. F of x equals x squared. We're going to move everything to the left, 3. So we can just count 1, 2, 3. And that'll be the first transformation. Okay, and if you want to know what the coordinates are going to be, moving to the left 3 only affects the x value, right? So this should be at -5, 4. This should be at -4, 1. This should be at -3, 0. This should be at -2, 1. And then this should be at -1, 4. for our vertical stretch by 2, right? We have a C value that's greater than 2. So we can multiply our y values by that C coordinate, or the C value, I should say. So you can use the points here, or you can use the points here. If you use the points here, make sure you're being really careful. We're at -3, 0 here. This is gonna stay. Here we're at -4, 1. We're only multiplying the y value, right? So -4, 2 instead. I'm gonna go over here. Okay, so see, it's a little bit narrower there. It's not very pretty. I apologize. I'll show it to you on Desmos as well. We're going to reflect that over the x-axis. So you can leave this one here. You can count how far away these are. 1, 2, 1, 2. This one is 8 away, so it should be 8 away in this direction as well. And for your chart, if you want to do the reflection over the x-axis, remember here the y coordinates are going to become negative. So this should be -5, -8, -4, -2, -3, 0, -2, -2, and -1, -8. And then our final transformation is to move up 1 unit. So again, we can take these and we can move up 1. And that should be our final graph there. Only going to be affecting the y value in this case. Up and down only affects y. So this would be -5, -7, -4, -1, -3, 1, -2, -1, -1, -7. I'm going to erase everything except for the parent function in purple and then the final function in red. Just so we can get an idea there. Oh. But here will be a nicer picture than what I have on there. So you'll see the vertex is at -3, 1, right? That's our vertex here. And then we're symmetric about that point. -5 is at -7, -1 is at -7, -4 and -2 are both at -1. I hope this video clarified some things for us. We are going to do an additional example like this one in class. Sorry, that's my son. We'll finish up and go over any questions, and then we will extend the due date for that 1.6 homework. Have a great night, everyone.